Do you know how the HEPA filter captures the airborne contaminants in pharma clean rooms? Or what happens at a micro level within the filter medium that stop these extremely fine particles from entering the clean room? Knowing about this filtration process will give you deeper understanding about how the filter works or how this capture mechanism works, and also this will help you make better decisions while purchasing or replacing a filter or during your pharma clean room maintenance. Hi, I'm Omkar Tilve, a clean room engineering coach, and in this video you will learn the 4 particle capture mechanisms of HEPA filters in pharma clean rooms. And I suggest you take notes while watching this video, because when you listen and you write, that is when you retain value rather than just listening. So take notes. To make it simpler for you, I have categorized this concept into 3 categories, which is the what, why, and how. So to begin with, let us see first what is a HEPA filter. A HEPA filter is short for high efficiency particulate air filters. Now these air filters, in this air filter, the medium is made up of crisscrossed glass fibers like a fine mesh throughout the depth of the filter, and the diameters of these fibers range from 0.1 micron to 10 microns. And you have to note that the gaps between these these crisscross fibers, is very much larger than the particles which are to be captured. Now you'll wonder, like, if the gaps are very much larger, then how the particles are being captured? To know that, you'll have to first understand what is a particle capture mechanism. The particle capture mechanism, what happens is the air stream passing through the HEPA filters contain particles which are considered as contaminants as per the clean room standards. This can be dust, pollen, human hair, human dead skin cells, etc., or any process residue from the clean room. Now, the method by which they are retained or captured by the filter medium is called a particle capture mechanism. And this happens because when a particle hits a fiber, strong forces like van der Waals are established between the fiber and the particle, and this retains the particle. Now, let's see, why is it necessary for you as a pharma clean room engineer to know the particle capture mechanisms? Now, what happens is different particles behave differently in the airstream depending on their size and mass. And also the capturing method differs according to these characteristics. And if you know these capture mechanisms, this will give you deeper understanding about the filtration process of HEPA filters, and it will help you while taking decisions regarding HEPA filters. Now, why is a HEPA filter used? As per studies, it is proved that it can theoretically remove at least 99.9% of airborne particles with a size of 0.3 microns. Now, you'll ask, like, why that particular figure 0.3 microns? It is a very interesting experiment, and I'll make another video regarding it. Now, let us get into the main topic, which is how are the particles captured in HEPA filter? And this leads to the 4 particle capture mechanisms. The first particle capture mechanism is called diffusion, and this occurs in case of particles not having sufficient mass to leave the airstream, and they move about randomly because of this. And as they move randomly, they also hit the fiber randomly, and when they hit or bumps the fiber, the strong forces like van der Waals are established and particle is retained on it. Now this is for the smaller particles. Now here is an animation of what happens in case of diffusion mechanism. The green area in the center is the cross section of the glass fiber. The red dot is the particle or the contaminant which is to be captured, and the arrow depicts the path in which the airstream flows, and the blue path is the path traced by the particle as it moves randomly. Now here you can see, as the particle is having very less mass, it moves randomly in the airstream and hits the fiber as it in a very random manner. And the second one is impaction. Now, impaction occurs in case of particles which are large in size and which have sufficient mass and momentum to leave the airstream due to inertia. Now, if stream curves around the fiber, these particles doesn't curve along with the airstream, but rather they leave the airstream and hits directly on the fiber. And as we know, if the particle gets hit on the fiber, it gets retained. Now this is an animation of the impaction mechanism, and as you can see, as the particle is bigger in size and with more mass, it is able to leave the airstream when the air curves around the fiber. So this is what happens during impaction. Third particle capture mechanism is interception, and this occurs in case of particles moving in line along with the airstream. Now we have spoken about two types of particles. The one is the smaller size particles which move randomly due to their size, smaller size, and the second one was large particles which leaves the airstream because of their large mass and due to inertia. But these are the particles which are medium size in between those two sizes, and what happens is they move along with the airstream, but as the airstream curves around the fiber, these particles get stuck to it tangentially. Now this animation is an example of interception mechanism where the particle neither moves randomly nor leaves the airstream, but rather moves along the airstream. And as the airstream curves around the fiber, it gets stuck to the fiber tangentially due to the establishment of the strong forces such as van der Waals forces. The fourth particle capture mechanism is called straining, and this occurs in case when the gaps between the fibers are smaller than the particles which are flowing. This is not a case for an HEPA filter, but there may be some particles which escapes the pre-filters and gets hit on this, and they are strained in the HEPA filter in this manner. To give you an example, it can be like a water strainer that we use in the kitchen. Here you can see an example of the straining mechanism where I'd given an example of a kitchen water strainer. So it is a similar concept where the gaps between the two fibers are very much smaller than the particles which is to be captured, and this happens in a very rare case if one of the bigger particles escape the pre-filters and reach the HEPA filter. Now that we have covered all the particle capture mechanism, it can be a bit overwhelming and hard to understand if you're listening to this the first time. But to make it more simpler for you to remember, you can remember this as smaller size particles are captured by diffusion. The large size particles are captured by inertial impaction, and the medium size particles are captured by direct interception. So this was the 4 particle capture mechanisms of HEPA filters in Pharma Cleanroom, and I hope you learned a lot from this video.